So welcome back. This is lecture number 8, and in today's lecture we are going to see the Galileo principle of relativity and Newton's differential equation. Okay, you might have seen that several places we are using either Newton's equation directly or Newton's like equation. Okay, so there are several variant of rate of change of momentum equal to force, second law of the Newtons basically we are using, and similar kind of variation we are using in several places. Okay, so we are trying to understand that whatever Newton's differential equation, how that is restricted using the theory of the group. Okay, particularly the Galilean group we are telling, or Galilean principle of relativity we are trying to understand using the notion of group. Okay, obviously in this process we are also able to understand that why state space representation becomes so much dominant, okay, so much relevant. Okay, so in today's lecture I am going to explore some more mathematical apparatus which will give some kind of window to understand the mathematical modeling, particularly for some kind of mechanical system, electromechanical system, some kind of electrical system, or some system that is also from thermal or these kind of things. That will give us the window to understand their concepts. So several times you might have seen that I am recalling this structure, because using this structure I am trying to understand the whole development. So in today's lecture, obviously I am going to use the concept of group. Now at least I hope that you are able to familiar with group. You are also become familiar that if I have some kind of coordinate axis, and if that will do passive rotation, means object remains fixed, but if axis will rotate, then that is going to form some kind of group. Okay, so during rotation what happens, automatically some kind of matrix kind of structure that involve in the previous class we have analyzed this. Okay, and what we found that some kind of orthogonal, a special orthogonal group you can tell, that comes into picture. Okay, similar kind of things we have also observed for the translation. Okay, and if you see the motion of any object or any rigid object particularly, then that is combination of translation and rotation. Okay, so this combination, each one is forming a group. It is possible to show that composition, because in the previous class what we found that if I have two function, then their composition is also form some kind of group. Okay, so and all motions are actually composition of rotation and translation, some kind of uniform motion. So it is possible to show that group kind of structure is preserved. Now one more thing that I haven't dealt till now, that this particular structure, algebraic structure, that is called vector space. Okay, so I am going to discuss this particular object in very much detail, but in today's lecture, in order to understand that structure, I need some help from here. Okay, so due to that reason I have actually again trying to discuss this particular way of structure. So you can see here that I have group, and in group I am just considering one operation. By one operation you can see here that I am talking about some kind of addition kind of operation. But whenever we are transferring from group to ring, then I am going to consider one more operation. Okay, so if you see ring carefully, then I have two operation and some more axioms, means whenever I have to play with ring, then I have to follow some more rule. That is the meaning. If you come to the field, so again I have two operation, and you can interpret that operation is addition or multiplication. Obviously I have told you several times, addition means not classical addition, 1 plus 1 we are 2 it might possible some kind of relevant way to talk about the operation. Okay, and it means that whenever we are talking about this element field, so field element has two operation and they will satisfy all property. Here closure property, here associativity, identity inverse with respect to one operation. Again with respect to second operation also they will satisfy all property. Okay, and in this way it is possible to show. I am going to talk in much detail in this particular course about the field, that how basically field is relevant for us. And after that what happens, that whenever we are talking about the vector space, at that time I have some kind of field, and after that two operation I am going to talk about. One operation is called addition, vector addition that is called, and scalar multiplication. So what is meaning of the vector space? I have certain kind of space, and if you see carefully the element of a space, that is either we are representing in form of column vector. Okay, so suppose if I have three-dimensional space, then I am going to represent like this particular column vector. Okay, and each entry, since I am talking about engineering problem, so I am assuming each entry is real number. Okay, but for analysis you can consider that as also as a complex number. You can generalize it to xn. Okay, so either element in form of column vector, okay, or it might possible that is in form of some kind of matrices. Okay, you can see that whenever some rotation comes into picture, what we found that always some matrices are involved. Okay, and these matrices are depending on the dimension of the space as well as the angle of rotation theta. Okay, so it might possible that in vector space where we will talk two operation, that is called addition, vector addition, or a scalar multiplication, we will see that operation. But element, if you just see the element of the space, okay, that is in form of the matrices. Okay, after that it might possible that in our space I have third kind of element which may in form of functions. Okay, so functions either in form of column vector or some kind of matrices. Okay, so it might possible I have some kind of function which map from x to something like x, capital X. Okay, so whenever we are considering engineering problem, so engineering problem, whatever the physical variable, whatever the parameters, they are lying on these three spaces only. Okay, either that is represented in form of column vectors, either in form of matrices, either in form of functions, or combination of that. Okay, so in vector space, if I trying to incorporate something, because till now if you see the vector space, then what happens, I have some kind of field, and field contain two operation, addition or multiplication, and top of this element field means each element this has for some kind of operation, two boundary operation, and they will satisfy certain kind of axioms. Okay, that is called field. So if I collected all element from field, and after that if I will define two more operation, this is called the vector addition and this is called a scalar multiplication, then what happens, we are going to form some kind of vector space. And element of vector space means a space we are talking, so element in form of column vectors, in form of matrices, in form of function, or combination of that. After that, here you can see that I was talking about the operation, but one of the more relevant thing that is called, that suppose I have two element in vector space, how far they are from each other. So for that I need some kind of notion like distance. Okay, but what is difficulty here, that either element in form of column vectors, matrices, or functions. So suppose that if some element in column vector, and I will tell 1 and 2 and 2 and 1. So is it possible to write this kind of symbol or this kind of symbol or equality kind of symbol? Is it possible to write? Anyone? Which symbol is relevant if I am just talking about the vectors? What do you think? Antara, could you please comment quickly?
I'm not sure, sir.
So in this space, I have seen some answer probably. So not comparable. Okay, we cannot compare it. Okay, but at least we can talk about the equality. Okay, if 1 and 2 is here, 1 and 2 is here, then we can tell that is equal. So equality can be defined in higher dimensional space, but I cannot define this less than or greater than. There are the way people are telling that one can define, but higher dimensional space, there is no priority that which one is greater and which one is smaller. And due to that reason, if we have to compare something, only one way, I have to map something to one dimensional space. Okay, and one dimensional space, everything is ordered. And what is meaning of ordered? That I am telling that I have some kind of real number. So you are able to see that if you map some quantity here and here, then we are able to tell that okay, this number is higher than or this number is higher than this number, or this number is lower than this number. Okay, so one of the way whenever we are talking about the comparison or distance, at that time I have to map from higher dimensional space to one dimensional space. Okay, and due to that reason, I am going to involve something inside the vector space in order to compare something. Okay, so in today's lecture I am going to use two things. I am going to talk about vector space, means I have some kind of field. Field means set with two different operations and which will satisfy certain kind of axioms. For time being, don't worry about the axioms. After that, what is meaning of vector space? I have a space somewhere where element is either in form of column vectors for us, matrices, or form of functions. Okay, and they will satisfy these two operations, and obviously again some rules they are going to satisfy. And after that you are able to see this inner product space, where basically we are going to talk something like distance kind of notion. So vector space, and in that inner product space I am going to, now I have to compare something. So I have to map from n dimensional space to one dimensional space, like that, because comparison is only possible in one dimensional space. Okay, so with this tool, now we are going to try to understand the principle of relativity and determinacy. Okay, so try to understand that why calculus becomes so much famous. What calculus is telling, that if you know the rate of change of some process, suppose I have this process, so this is autonomous differential equation, because here there is no forcing function, and suppose that for time being you can assume that x belongs to r, some kind of real number I am assuming just for simplicity, but you can extend it for rn also. Okay, so what basically we are telling, that if I know the initial condition xt0, then I can able to talk about xt. So in form of block I'm writing same thing like this. If I know the xt0, so t0 is time of start of our experiment, and this is our rate of change of that, then I am able to predict the future xt. Okay, so Newton's has given certain way, and they are telling that if you know the rule rate of change of some quantity, and if you just know the initial condition, then you are able to predict the future. Okay, so try to understand here that in this formulation two things are required. One thing, that is xt0, you can interpret xt0 if you are in one dimension space, that as a position. If you are in higher dimension space, you can interpret xt0 as a position vector, and x dot you can interpret as a velocity if you are in one dimensional space, otherwise velocity vector. So you can see that if I know the position and velocity vector, okay, then velocity vector at all time and position at only one time, then I am able to talk about position at any time. Okay, so somehow we are able to guess the future. So suppose that if you are going to buy some kind of bread, and there that is written that is valid up to 7 days. Okay, so how basically they are predicting that is valid up to 7 days. Okay, so what happens, they know that some kind of bacteria that is going to grow on this bread, and they just trying to do their model. Okay, mathematical model might be on observation, might be on data driven, okay, might be on differential equation. Okay, so they are just predicting, so they have some kind of rule, and using that rule they know that number of bacteria is going to grow after 7 days that will harm us. Okay, now similarly whenever we are buying some kind of air conditioner or any kind of washing machine, any kind of product, you might have seen they are predicting the life. They are telling that we are going to give guarantee for 10 years. Okay, so every time they are knowing, company is knowing by doing some kind of analysis, some kind of mathematical analysis, that up to what time whatever output that is going to come into picture that will survive or that will satisfactory for the user. Okay, so due to that reason differential equation becomes so much famous. Anyone has confusion on this particular concept, then please let me know. Okay, if you don't have, now let us come here. So what is objective? To introduce and discuss the notion of inertial coordinate frame. Okay, because during school time we are knowing that whatever classical mechanics that is valid in inertial coordinate system. Okay, we are trying to explore that why we have considered this inertial coordinate system. Okay, and what kind of restriction basically comes into picture. Okay, so now since we are mature guy, we are not 10 plus 2 student, so whenever we are going to do mathematical modeling, okay, because our country is planning for several space missions, several defense products, several products for agriculture, and at that time we have to become very careful whenever we are designing something. Okay, so you can see that actually if you see the classical mechanics, that is based on several experimental facts. Okay, and list of them are like this. So classical mechanics is telling that I have a space and time, so I have to represent a space in certain way, I have to represent time in certain way. Okay, after that I know I want that whatever law I am going to formulate, that is going to valid in some relevant spaces. Okay, suppose if some law, whatever law I have given, if that is only valid in one place, one experiment, then that is not a law. Okay, and due to that reason what we found or what we expect at least, that whatever law I am going to give, that will valid in higher means large number of system, large number of space. Okay, so I have to understand in some way that in which kind of a space whatever law that is formulated by someone, suppose that Newton's law, that is valid. Okay, and it is possible to show that at least where this kind of condition will satisfy, at that time I can apply the Newton's principle of determinacy. And what is Newton's principle of determinacy, I have already told you. Okay, now let us try to see the structure one by one. Okay, I will talk in detail in the latter part of this. One space, our space is three-dimensional Euclidean. Here you can see that that one term, that Euclidean, comes into picture. And what is meaning of Euclidean? A Euclidean space is finite dimensional vector space. Okay, what is meaning of finite dimensional vector space, we are going to learn in this course. Okay, but for time being you can just try to understand that whatever element inside the space, okay, that has finite number of entry. Okay, then I am going to tell that as a finite dimensional. Obviously I have to define in terms of basis, but at this point I cannot talk about the basis. I don't know how to define basis, how to define the dimension. So for time being you can just consider that suppose if I have two dimensional space, then using two numbers I can represent this space. Infinite means I need infinite many numbers to represent some quantity. Okay, for time being. over reals are. Okay, I have already told you that whenever we are performing some kind of experiment, whatever apparatus we have developed, whatever sensors we have developed, that is only able to collect the real data or able to understand the real data. This is due. And after that, inner product means some way to define the distance. I will talk about that. So this is the space, our space. Now second thing, that Galileo principle of relativity. So what basically they are telling, that there exists a coordinate system called inertial, possessing the following two properties. All laws of nature at all moment of time are the same in inertial coordinate systems. Okay, so suppose that if you select two inertial or three inertial coordinate system, okay, and if you are searching the law at some moment, so laws become actually exactly same in all coordinate frame. Okay, all coordinate system in uniform rectilinear means those who are moving with respect to some kind of uniform velocity in one particular direction with respect to an inertial one are themselves a inertial. So these two things are basically defining the inertial frame. Okay, mathematically we are trying to understand this statement. Okay, so in some experimental sense, you try to understand that, suppose that I have some kind of train, and I am assuming that our earth has a inertial coordinate frame. Okay, that will satisfy these two property. So if train is moving with uniform speed, and suppose that we are inside the train, inside any car you can take inside the train, and if you perform some kind of experiment to measure the velocity, okay, of that train, it is not possible. So that kind of things, basically this principle is imposing. Okay, we will see this kind of point in more detail. Now I have already talked about what is meaning of Newton principle of determinacy in the previous slide, that initial state of mechanical system, the totality of position and velocity of its point at the some moment of time, you uniquely determine the motion. Okay, what I have told you, that if I have some kind of differential equation, okay, so if I know the position vector and velocity vector means rate of change of some quantity, then I can able to talk about the futuristic value. So that kind of information basically coming from here. Okay, so basically whenever we are talking about the classical mechanics, that is based on the experiment, and they are basically characterized by these three things. Okay, so using mathematical language we are trying to understand this, and after that we are using mathematical tool, we are trying to understand that where basically this principle are valid, what kind of restriction basically comes into picture. Okay, up to here anyone has confusion, then please let me know. Now let us try to, if you don't have confusion, then I will proceed further. Now you can see here that I have suddenly written one thing, that Galilean group and Newton's law. Okay, so here what basically we are trying to understand, objective is to define and investigate the Galilean group of space-time transformation. Okay, what happens here, that I have a space. Okay, I know that I have some kind of three-dimensional space. I know I have some kind of time which is moving in futuristic direction. Okay, so engineering system people are doing like this, but it is, you have to become careful that whenever I am writing this, okay, what happens, why people are writing like this, sometime we have to see in past also. Okay, we have to see that, suppose I have tree, we are trying to understand that how much older that is, for we are using carbon dating or these kind of things, and you all are already familiar that some differential equation also comes into picture. Okay, so whenever we are writing like this, it means that I try to understand some phenomena in past and some phenomena in future. Okay, and and what basically we are trying to understand, that if my system in some space, okay, so now here whenever I am talking about a space, you know that there exists some kind of reference frame. Okay, so suppose this is Earth I have taken as a reference frame. After that, it might possible object might be here, or something that with respect to Earth. This is Moon, at some object on Moon. Okay, so now we have to understand that how basically if different space, then what kind of mathematical restriction that comes into picture. Okay, and that particular thing is nothing but Galilean group. We are trying to understand. Okay, so now let us start with some notions. Okay, in order to understand this, some notions are required. So I hope that most of things you are knowing. Set of all real number. Several times I have told you that set of real number is represented like this, and Rn means n dimensional real vector. It means that if I have some quantity like position vector x2 and up to xn, so I can represent this as a real number, Cartesian product real number up to n real number, and at the same time I can able to write Rn. Okay, same kind of things that is written here. Rn is a n dimensional real vector. Real vector space means each entry is real number. Okay, now let us try to understand this figure. Now suddenly I am going to talk about something that is called affine n dimensional space. Here I have talked about the real vector space. Now I am going to talk about the affine n dimensional space. Okay, so how basically that is distinguished from the Rn means real vector space, that in An there is no fixed origin. Okay, so what happens, it might possible that if I fix the origin at the Earth, so some object is here, they are moving. Okay, so their origin is not fixed. Okay, I am assuming that now what happens, that there exists some kind of local origin or local coordinate frame to every object. Okay, but here this space that is lying on Earth, where that is some kind of real vector space, because here origin is fixed, but here origin is basically moving, not fixed. Okay, now you can see that, is it possible to show that Rn form a group? Is it possible to show? Anyone, could you please comment? Rn will form a group or not with respect to addition and multiplication? Could you please check? Rn will form a group or not? First try to convince yourself that R form a group or not. Okay, in the previous class we have already seen that R form a group. Why? Because if you add two real number, then that will give you real number only. Identity is well defined, inverse is well defined. Anyone has confusion why R will form a group? Now Rn will also form a group, because if you take the component wise addition of two vectors, okay, then what happens, that individual vector is going to add. Okay, so due to that reason they will also going to form some kind of group with respect to addition, at least with respect to addition, that will form the group. Okay, now due to that reason I have written the group Rn acts on An. Okay, what is An? An is some kind of a space, a fine space where origin is not fixed. That is just difference between these two space. So I have one space that is called real dimensional n dimensional real vector space where origin is fixed. Okay, and they will form group. Okay, I am not specifying here what kind of operation, just but at least one operation they will form a group, acts on An as the group of parallel displacement. So let us try to understand this. You can see that A is here and I am defining A plus B, and here A is in An. An means affine space. B is in Rn. Okay, whatever displacement here I have considered, that is in real vector space. Okay, so whatever resultant quantity A plus B that comes into picture, that is not going to lie on this space, that is going to lie in An. Okay, because if origin is not fixed, at least at one space, then we cannot tell that we are going to lie on fixed space only. Okay, so this lie in an, that is a fine space, and after that, here after some kind of translation, here translation I have defined B, or some kind of displacement I have defined B, that is on real vector space. Okay, so you can see here that this kind of things comes into picture. So at least from this expression you can see that I do not know that how to define a plus b, because a plus b is going to lie in an, but at least I can able to define a plus b minus a, because that will be, if I will do a plus b minus something like a, then we know that belongs to some kind of Rn. So here at least I can able to define this kind of things. Okay, relative distance at least I can define in this space. Okay, anyone has confusion on this? So same kind of things I have written here. I hope that you are able to understand. Sum of 2 point in an is not defined. Okay, because I don't know the origin and I want to consistent with respect to group property, but their difference is defined in the vector in Rn. Okay, a Euclidean structure on vector space Rn is a positive definite symmetric bilinear form called the scalar product. Okay, what does it mean? I have already told you that whenever we are talking about the distance, okay, so distance I can define, suppose that if you have to define distance between x and y, so you are able to define x minus y transpose p x minus y, that is called the generalized form of distance. This is d square, you are able to define. Okay, and here you have to if you see carefully, this is positive symmetric definite matrix. So do you have knowledge of positive symmetric definite matrix? Anyone? During modern control engineering course, you might have learned about positive definite matrices, positive symmetric definite matrices. Anyone has confusion? Just you can assume that I am going to talk about those kind of symmetric matrix where all eigenvalue are positive. In this course also I will talk about positive symmetric definite matrix, because that is very important. You can see that one of the main implication that we can able to define the distance. So to any distance between any 2 point, one can define using this kind of the way. Okay, so and due to that reason, now you are able to predict that whenever during school time we are defining distance like this, if we are in three-dimensional space, we are defining x square, y square, z square. If I have to define distance between here and here, then x1 y1 and x2 y2 we are taking, and after that x1 minus x2 square plus y1 minus y2 square we are doing, and the square root of that. Same thing they are telling. Suppose you can take x equal to x1 x2 up to xn, and y you can define like, suppose in that vector space real n number, this is belongs to Rn, this also belongs to Rn, you can assume, or you can assume that that belongs to an, a fine space where origin is not fixed. Now if you take the difference between these 2 points, I have told you that difference can be defined, because again once you take the difference, then whatever shifting of the origin, that is going to vanish, and due to that reason again I am in some kind of real dimensional space, so I can able to define. What does it mean? That whenever we are talking about a fine space, so those kind of a space where origin is not fixed, but apart from that they will contain, if they will contain this way to represent any distance, then that space is called Euclidean space. Okay, and most of time whenever we are learning something, you might have seen that we are talking about Euclidean space, Euclidean space. Sometimes people are not understanding. Okay, so I have a fine space. A fine space means same like real Rn space, but origin is not fixed. Okay, now I have Euclidean space. It means that I have two things, a affine space, and with I know that how one can able to compare 2 points, then that space is called Euclidean space. Okay, and whatever Newton's law we are talking, that is valid in this space. Okay, have you heard about some other space? Anyone? Apart from Euclidean space, have you heard about some more names? I'm not talking anything, just if someone has heard about some space, then please let me know. Anyone? Have you heard about something like non-linear space, Banach space, Hilbert space? Have you heard about these kind of names? Anyone? Yes or no?
No, sir.
Okay, don't worry about that. We are going to tell you the story of all, at least I will talk about the Banach space, Hilbert space, and now whenever you are going to see any paper, then you are able to understand that what is meaning of that particular space and why basically we are not concentrate only on Euclidean space. Okay, so at least I hope that you are able to understand the Euclidean space. Euclidean space means I have some kind of a space, okay, where I have each entry can represented by some kind of real number, but origin is not fixed. Okay, and I have some way to denote the distance. Okay, and I have written that d square is x minus y transpose p x minus y. So you can select p equal to identity matrix because that is also positive symmetric definite matrices. Okay, now let us come. So at least I understood now that what kind of space we are talking about and how I can compare 2 points in the space. Okay, now let us come to the another thing that is called Galilean structure. Okay, because somehow I have to relate everything. So whenever we are talking about Galilean structure, so they are talking about three different things. One thing is universe, third thing is time, and second thing is time, and third thing is distance between simultaneous events. Okay, I have to define what is meaning of simultaneous event. Okay, so if you see the Galilean work or some work of the mechanics, means obviously for higher dimensional mechanics, at that time people are defining each and everything. Okay, so now whenever we are talking about universe, so our universe a four-dimensional affine space, and I have already told you that what is meaning of affine space. I have four tuples of real numbers now, and I am assuming that origin is not fixed. Okay, so this is our space. So I have defined that space, means I have some quantity that is going to represent in 3 dimension plus one more quantity that is time, and due to that reason you can see that a4 that comes into picture here, and a4 and here one is time, and a4 are called the world point or event. Okay, so this is the world point basically, or parallel displacement of the universe a4 constitute a vector space r4. Okay, so if you see the parallel displacement, okay, it is possible to show that that is going to constitute some kind of vector space. This kind of things I will discuss once I am going to talk about the vector space. Okay, so for time being you can believe on me, parallel displacement in this universe is going to form some kind of vector space. Okay, and you know that if I am in vector space, then I can manipulate anything. Okay, and from here if you are able to manipulate anything, means I want, whenever I have a space, I want something parallel kind of displacement I want. Okay, then my rule become, whatever law I am going to formulate that become relevant, I can able to manipulate that law. Okay, even if, because in a4 space I don't know the equilibrium point, I know that how to identify the distance between 2 points, but I do not able to manipulate each and every entry. Okay, but if I just going to concentrate on parallel space, then automatically that form a vector space in R4 and I start some kind of manipulation. Okay, so we will see this point. Now time at linear mapping TR4 to R, I have told you that time means here space and time both are progressing, but finally time is mapping from R4 to R. Okay, form a vector space of parallel displacement of universe to a real time axis. Okay, again here you can see that I am talking about parallel displacement only. Okay, now time interval between two events, suppose I have one event here and second event here. Okay, so time interval I am going to define like t b minus a. Okay, and suppose that if b minus a both event is occurring at the same time, at that time what happens that t b minus a equal to 0. In this way I can tell that a and b are simultaneous event. Okay, so in order to define simultaneous event, if I will tell that in some space a4, a fine space, I have two events and both are going to occur simultaneously, then I have to make sure that t b minus a, and here this is kernel people are telling. I will teach you that when I will talk about the vector space. So several things I am teaching in advance, and after that once I will teach vector space, at that time I will correlate. But you have to understand first that what kind of requirement I have, then you are able to enjoy the vector space. And due to that reason I have, first I am going to, because you have some idea of vector space, that some space where we have some kind of element, I have two different kind of operation, certain kind of rule, and that rule is going to follow. Okay, just you have to check that. So a4 space, and if I am going to talk about parallel displacement, then now just we have to check that all property is going to satisfy or not. If that is satisfied, then that is vector space, otherwise that is not a vector space. Okay, so in this way I am able to define the simultaneous event. One more thing is missing, so I have defined the, in universe I have defined the time, I have defined the simultaneous event, and now I have to define the distance between 2 points. Okay, so we have already seen that distance between 2 points, if we are in a4, so something, because finally I have to manipulate the real number, so whatever things we will do, finally I have to make sure that real number comes into picture. And due to that reason what we have to do, that since I don't know how to add two things in a cube, but at least I know that how to take difference of two things in a cube. A3 means affine three-dimensional affine space, and due to that reason I have defined distance based on the subtraction only, not by addition. Anyone has confusion? Okay, the distance makes every space of simultaneous event into a three-dimensional Euclidean space. Okay, so now you can see that I have some kind of a space like a3. Okay, and I have some kind of time. I am not considering, time is always a real number, so I am just considering this space, and I have this way to talk about the distance, and whatever things that comes into picture, that is again some kind of real number. Okay, but here this is the scalar product in R3 space, means real, because a and minus b is some real number, a minus b is again some real number. Okay, that map to R. Okay, so basically finally if I will take a fine space with this kind of distance, then what happens, I have Euclidean space E3. Okay, and in Euclidean space now I can able to manipulate everything using real numbers. Okay, now let us talk about the Galilean space. You can see that so far I am talking about Euclidean space. Now I am going to talk about Galilean space. So in Galilean space I have some more quantity, that is time. Okay, so if you are also going to consider the time, then at that time our space become Galilean space. So a space a4, a fine space of fourth dimension occupied with Galilean space time structure is called Galilean space. Okay, so Euclidean space time is not involved. Okay, in Galilean space we are going to involve the space time structure. Okay, and in this particular space time structure what I am telling, that the set of events simultaneous, and we have defined what is meaning of simultaneous event. If that is 0 and b and a, this belongs to a fine space, then we are telling that as a simultaneous event. If that is not, then that is not a simultaneous space. It is called a space of simultaneous event in A3. Okay, So I hope that you are able to understand the difference between Galilean space and Euclidean space. In Euclidean space, I don't have notion of time. In Galilean space, notion of time also incorporated. Okay. So one can speak that two events occurring simultaneously in different places, but the expression two non-simultaneous event A and B occurring at one the same place in three-dimensional space has no meaning, as long as we are not going to choose a different coordinate system. Okay, so suppose that if we want to make sure that two events is going to occur at the same place, then we have to select two different coordinate system. Okay, so now whenever you are going to manipulate something, those who are working on robotics or that kind of system, and suppose that you have to generate something at one place. Okay, so it is possible to show that in order to tell your machine that two things is different, you have to select two different coordinate frame. Okay, one might be body coordinate frame, another may be some kind of coordinate frame which is going to sit on the earth or something like that. Okay, Galilean group and transformation. So Galilean group is group of transformation of Galilean space which preserve this structure, means space time structure, and element of that group is called Galilean transformation. Okay, so today I am just going to give you hint of Galilean transformation, and after that in next class we are going to explore the Galilean transformation using the group. Okay, so the Galilean transformation are affine transformation of A4 which preserve the interval of time and distance between simultaneous event. Okay, that kind of things we have to make sure that only I am going to talk about those kind of transformation which preserve the interval of time and distance between simultaneous event, means something invariance is required. Okay, and if you see that if I consider some kind of a space direct product where everything is real number, then obviously origin is fixed, so this space is nothing but they have Galilean kind of structure. Okay, so let us try to see some kind of Galilean transformation. Okay, so these are the Galilean transformation. Okay, in Galilean coordinate space is, now I am going to talk about time as a real number and a space as a R3. Okay, so you can see here that it means that whenever I am talking about Galilean coordinate system, then I have Euclidean space and time as a real number. Anyone has confusion? Now you can see that uniform motion with respect to v. Suppose that g1 is some kind of Galilean transformation, then if this kind of things holds, that t and x plus vt. Okay, so uniform motion with respect to v. Translation we are defining like this, and rotation we are going to define like this. Okay, in the previous class we have just not talked about the time, and if you see carefully, then at least I have talked about rotation and translation, and what we have seen that they are going to form the group if this time is not present. Okay, now we are going to see that if time is present, then still that is going to form group or not. Okay, and uniform velocity means that x in place of x, you can see that s is there, similar kind of structure vt is there, so time is involved, and due to that reason this kind of things comes into picture. Okay, so again it is possible to show that everything is going to form the group, and in linear algebra orthogonal transformation is a linear transformation. Again I am going to talk about linear transformation when I am going to talk about the vector space is a inner product space v, and that preserve this kind of things. Okay, so just try to understand that whenever we are talking about any Newton's law, at that time I just need three things. I need something will move with uniform velocity, translation of the origin because origin is not fixed sometime, and rotation. Okay, and it is possible to show that with this combination I can represent anything if we will restrict ourselves in Galilean group or Galilean coordinate frame. Okay, so in next class I will discuss the rest. Okay, and after that I will tell you that what kind of restriction basically comes into picture. Okay, so now it is time to conclude the today's lecture. So what basically we have seen in today's lecture, that whenever we are defining some kind of law, at that time I have to define each and everything mathematically. And why mathematically we are trying to define? Because mathematical things will give us the idea that in which situation something is going to occur, even if we are not able to perform using some kind of experiment, using experiment, but at least we can we are become sure that if this kind of situation comes into picture, then whatever result we are going to get, that become valid. Okay, and that is also gives us one of the way to cross check our result. Okay, so in today's lecture I have talked about Euclidean space, I have talked about the Galilean space, and after that I have just give the hint of Galilean transformation. I have also talked about the Newton's law of determinacy. Okay, what is meaning of that? And if you see carefully, that Newton's law of determinacy is nothing but they are telling that if I have position vector and velocity vector, then I can able to know the future. So now if you have higher dimensional space, then what you can do, and suppose that something is represented by nth order of differential equation, higher order differential equation. So what you can do, you try to represent that using first order differential equation, and again you can apply Newton's kind of law. And but at that time automatically you have to be sure that there exists some kind of Galilean group. Okay, then only that kind of things is true. Most of time that is obvious, due to that reason people are not checking. Okay, but whenever you are talking about a space or these kind of things, there certain kind of restriction comes into picture. Okay, so using mathematical modeling we are trying to understand that restriction also. Okay, so with this remark I am going to end the today's lecture. If you have any questions, please let me know. So what I am suggesting,
Sir, can you please share the slides which is being discussed in the class?
so actually what I am not sharing, I am going to write one book. Okay, it might possible some student will upload somewhere, and that will not satisfy the means privacy of that particular means suppose a Springer or somewhere, so they are not telling that whatever book you are writing, that material should not upload anywhere, and due to that reason most of time I am not sharing. Okay, so sorry for that. Okay, because I am trying to write one book that is based on physical significance of mathematical method, and last 4 to 5 years I am teaching, and after that I found that there is no some kind of consistent book such that they will explain or they will motivate engineers to read mathematics. Okay, and due to that reason I am writing. So I have finished some part, and from that only I am making slide and showing that kind of things to you. And due to that reason you but whenever this is in picture form, and if they will do Google search, then they are not able to find this kind of content, and due to that reason means I'm not saying, so sorry for that. Okay,
Okay.
so thank you very much. If you have any questions or any suggestion, if lecture speed is fast, it might possible that at this moment you might seen that lecture is little bit abstract. Okay, but please do not worry, after once modeling will started, at that time I am going to use these kind of concept, then you are able to appreciate lot of things. Okay, so thank you very much.